Minimum number of moves to seat everyone. You're given an array of seats and an array of students. Seats at index I is the position of the ith seat, and students at index I is the position of the ith student. Our goal is to place all the students in a seat. In order to do so, we are able to move a student by increasing or decreasing their position by 1. Return the minimum number of moves required to move each student. For example, we can move the student at position 2 to seat 1 by decrementing its position by 1. Now, let's move student at position 7 to seat 3 by decrementing their position by 4. And finally, let's move student at position 4 to seat 5 by incrementing their position by 1. Notice, if we add up all these values, we get our total moves of 6. But in fact, we can do better. This is not the minimum number of moves to seat all students. Let's back up to this step in the algorithm. Instead of mapping student at position 7 to seat 3, we will map student at position 7 to seat 5 by decrementing their position by 2. And finally, we will map student at position 4 to seat 3 by decrementing their position by 1. And now notice the total moves we have made is even less than 6, that being 4. And this is in fact the minimum number of moves to seat all students. We will solve this in O of n log n time. To minimize the number of moves, we need to pair the closest student with the closest seat. The easiest way to do this is consider sorting the seats array and the students array. Sorting allows students to be paired with their closest seat, and this pairing will minimize the number of moves we need to make. Now all we need to do is calculate the absolute difference between the student and the seat in each pair. And once we calculate the difference, we add them all up, and this will give us the minimum number of moves to seat all students. And here's the code to do so. Please like and follow for more.